Hello, everyone. How's it going? Let me just ensure that there is no one who sends notifications. Do not disturb. Perfect. Okay. So, how's everyone doing? How has Global Hack Week been so far? Enjoying, not enjoying? Uh, Hopefully, you all have learned something new in the Global Hack Week that has been going on. I think there have been some interesting sessions, if I may say, uh, especially the webhook. I think there was a webhooks explained. There was intro to agent mode in GitHub Copilot. I think those have been some really good ones. Uh, and I watched the last bit of the mini AI assistant with APIs that was run by Vincent. So yeah, I think it's been going pretty cool. You have a lot of upcoming good workshops, and yeah, welcome everyone to the part 3 of hosting a website on ESP-32. If you have not checked in yet, let me first start by sharing the check-in link once again in the chat. It's already there, as you can see. It's like pinned in a banner, but otherwise you can still like take a look at this chat message that I have just sent. Would be easier to click on it and just register for it. Please do register for the event. Helps me, helps MLH. That's all I can say. Other than that, uh, let me give you a quick overview of what we have been doing and what am I aiming to do. And yeah, I guess what can we do about this, right? What can we do about the project? Where have we reached? Things that are upcoming, things that I guess would be nicer to have. So checking for any messages. Okay, cool. So the things that I have covered, or what has the this session been about? So this session has been about specifically using ESP-32 to and tinker with slash build things with, if I may say. Uh, we haven't built something amazing yet or very big enough yet, and I don't think we will. At the start of the sessions I said like these would be beginner level sessions, so yeah, it is what it is. Things that we have definitely tinkered around with is an ESP-32. Let me zoom in if for folks who may not have been there yesterday. So this is ESP-32, connects with Wi-Fi. I have connected it with my laptop right now. And we tinkered around with this. We tinkered around by just checking how do we install uh, MicroPython on it. So we talked about what is MicroPython. We installed it on ESP-32. We saw a lot of commands on, okay, how do we flash it, how do we ensure that the correct libraries are installed. We faced some errors, we resolved them. Yeah, this has been a very good journey so far, and everything that we did was noted on this readme. Then towards the end of second session, we actually created a blink.py and blink.instructions, where it has instructions on how to run this project on ESP-32. So we transfer over the files from our system over to our ESP, and we, on click of, not actually a click of button, we saw that, oh, it was flashing in the given time intervals. Then we also wrote a very quick Wi-Fi connect program, whose instruction was not actually added towards the end of session 2, but I have created it. So I have created a lot of things which I'll talk to you about. So I think our first half an hour would be spent on things that I have updated, things that I have added, things that I want you all to know about, I would say. Cool. So, yeah, we'll talk about those things. We'll talk about, yeah, the instructions that I've created. And if you all have any questions, then of course we will try and ensure that we uh, resolve them, right? So that is one thing. What else? So we'll talk about those bits. And now, what are we aiming? So step one, we connected with Wi-Fi yesterday. So we'll kind of pick it up from there. We'll connect with Wi-Fi again today. I have enhanced the Wi-Fi connection file, the Python file that we created. So I'll show that. I'll connect with Wi-Fi again. Then we'll build a very simple web server where we'll run the web server on the local machine, so on your laptop slash desktop, whatever you would say. So it will run on local machine. If you're connected to the same Wi-Fi, you can also connect to it via your phone. So from there, from that simple web page, we'll again try and just control the LED on our device, and that would be it. I think for session 3. For session 4, we are going to go a step further, which is the whole idea of uh, this these 4 sessions, which was building a portfolio website. So the idea that I have in mind is that we will have kind of a JSON file or something of that sort, which will basically be posted somewhere. Like you can try from GitHub. Okay, yeah, even though I haven't tried it from GitHub, but I think we should be able to try it from GitHub, uh, get access to a JSON file, read that JSON file, and parse data from it. Once we have parsed the data, then we can kind of have a website which would be up and running with what do you call it? With our portfolio page. We'll try and add some UI to it, like some bits and pieces of uh, CSS to it, so that it looks comparatively better. And yeah, excuse me. So that is what I'm aiming for. And if the time permits, then I'll also show how you all can access that portfolio website, because, well, it doesn't make sense for a web server to run just locally if it is a web server. I think it should basically run like you should be able to access it even if you're not connected to my Wi-Fi network, right? So yeah, I am going to try and ensure that there is time so that we can kind of make it public in a way so that you all can connect to it. Uh, all depends on the time that we have. If not, as I said yesterday, that please keep an eye on this GitHub repository. Any instructions will be updated here. So if I have not shared it, which I don't think I have, let me share the GitHub repository. And thank you to all the 6 people who have started this repository. Really, really, really boosts my ego. Okay, cool. Uh, yeah. So there is the GitHub repository. Any questions before we go ahead from anyone? Okay, cool. Going to take the silence as golden and GitHub repository just for your access. Now, uh, I'm going to basically ensure that you see the maximum pieces of code, maximum bits and pieces of code. Let's start with blink.py. So there is one change that I did in blink.py, which is yesterday we saw that we had this not try, we had this while true part. So I can actually show you the diff between what we had yesterday. So Okay, there is one question. Wait, let me first answer that one. If I didn't attend past ESP sessions, is it okay to attend this one? I would say yes, but there may be a few terms that I will use, and it's possible that you may not know it, or it's possible that you may think, what is this bit that I'm talking about? But that's completely fine. You can kind of ignore that part. And otherwise, I think most of the thing that I will like right now show on screen, which is from yesterday to today, what is the difference between the things that I've created and added and removed, you should be able to pick up everything about ESP. Well, I'll try, as I said, like I'll try to cover kind of a revision for the first half an hour. And I say revision, but it is new code, so or updated code. It should be fine. Okay. Okay. So coming back, so yesterday this is what we had our blink.py project where we had written this while loop where we said that the LED on our ESP32 it will be on for some time, then we'll print LED is on, and then it will go to sleep, and then for 1 second, and then it will turn off. Then again it will print LED is off, and it will be off for a second. So on and off every second. That's what it was doing. And even if I come out of the REPL, I come out of ESP32, it would still keep the program running in the background, which we saw. So now, depending on what you want to do, you could technically make a change, which is you can add a try catch around it in Python. So you can add a try except around it where you say like try to do this except when something occurs. Example in this case keyboard interrupt, which is if I press control C, which should, or control X, which should shut down which should shut down the REPL. In that case turn the LED off. So on off, uh, sorry, on exit the LED should be off, which is something that I wanted, so that the program does not keep running in the background on ESP32. So that is one change that I made in blink.py. Of course, I updated the instructions as well. So excuse me. So this was the previous instruction. I mean, it was good enough for understanding, but then I went down the rabbit hole of you know making sure that every bit and piece was understandable, uh, as to like what is this, how do I install the, like what is the program about, what is this code about, how do we install it from our system over to like ESP32 in our case, and how do I run it, and what should it print, what should that look like, so that I know, oh, okay, when I run this program, I should expect an output which should be something similar to this. And if I don't, then I know something has gone wrong. Uh, yeah. And what else? I also added a few bits and pieces, and then I asked for LLM for help. Okay, I told it that hey, I had added like these first bits, and then I asked LLM for help to enhance this instruction.md. So I asked Copilot to do it, and it kind of gave a very robust version of the whole blink.py instructions. It enhanced it like too much. It also found a mistake. LED in on, LED is off. So this in should have been is. So yeah, made a mistake there, which it corrected, which is pretty cool. So yeah, I think you can read through this instruction file. You can understand the code itself, and you can also then know how to exactly run it. Then similarly, I went over to the Wi-Fi Connect program that we had written. Yeah, I should have kept this one. Okay, so I enhanced it a bit based on what I was talking about yesterday. So most of it would be same kind of. Yes, I have not committed the changes yet. I wanted to show it before I actually push it. So that's why I have not committed the change. Okay, so I enhanced this Wi-Fi connect a bit. We already wrote a scan networks yesterday, so that is on the left, which is what we wrote, and on the right there is like line by line comment on what it is doing. Then I also wrote a disconnect and a status check function, and here we go. Like some extra instructions on how do we connect to it, how do we uh, like what functions or methods are available in a way for you to kind of try out. So example, to connect to Wi-Fi, you like to scan for all the available networks, you can do this. To connect to Wi-Fi, you can do this. Then you can check if there is a connection or not using the status one, or you can disconnect from Wi-Fi network using this disconnect. Okay. So these were not written yesterday during our sessions, but I wrote it later. Instructions again, of course, I followed them with the instructions which were missing yesterday. So there we go. These are all the instructions. What is there? Anyways. Okay, instructions that I wrote all about what is this, how it works, what should you see. Uh, yeah, that's it. Okay, there is. So there was this question which I answered, and there's this question: is this connected to a hardware component LED light by any chance? It is. Like the blink one is of course connected to the on board LED, not the red one. There is a blue one which will start blinking once we run the program. So I'll show that in a second. So instructions again, as I was saying, that it has all the details of what it has, what it doesn't. Did I remove the quick? Yeah. Good. Then I also created a quick connect for you to basically not do the whole connect again and again. So there is a quick connect where you have to enter your Wi-Fi name and password. So I did a to-do command. So if you have a Wi-Fi setup up and running at your house, of course you will, or you may have a hotspot. So in that cases, if you remember, and this is running on your local machine, then or running locally, I would say. Uh, I would just suggest that put your SSID and password here. But remember, do not commit this to GitHub because everyone will know your Wi-Fi name and password then. So uh, you can theoretically create a .env file. You can add the SSID and password in your .env file and read it from there. So that's also a good idea to have. Uh, read it from .env file. And sorry, uh, yeah, quick connect, and again instructions for it. You can add like how to use it, what to do with it. And then finally there's a blink with patterns. So there are multiple patterns of how do we can kind of control the LED, and all it depends on how much time it is on for and how much time it is off for. So there is a pattern fast, there is a pattern slow, there is a SOS pattern, there is also a heartbeat pattern, and that's it. Like all of them run when you run this program, so that should be fine. Comes with instructions, of course, as always. And I think yes, that is all of it. Let me now commit this, but I need to first set up my username, as you might remember from yesterday. But I have two of them, and it just keeps messing around between one or the other. Perfect. I've set up my username very quickly. Okay, so what I want to do is git add all, git commit. This is technically part of session 2. So I'm going to say Wi-Fi connect, blink Wi-Fi connect, and blink part. Did I have a dash in between? No. And git push. Okay, perfect. Oh, I also added this last bit, which was how to upload a folder or delete a file from the device. So you can basically see how do you upload a folder to your ESP32, for example, or how you can delete a file from ESP32. Doesn't have to be .py, but I just kept it .py based on all the syntaxes that we have been using so far. Uh, Please note that some of the instructions, I would say majority of the instructions of link with patterns and quick connect.py uh, are coming from AI, are LLM generated. The Wi-Fi connect.py has a mixture of my changes plus LLM generated code. Blink.py instructions also has my changes as well as LLM generated code or instructions in this case. So if you find any issues, feel free to raise a pull request and I will happily accept it and make changes if they are relevant. Uh, okay, cool. So that is kind of it. One thing that I want to do before we move ahead is run the blink with patterns.py project. So I am going to step one, uh, copy it over to blink with patterns.py file. Okay, it has copied it over. Okay. Next up, what I want to do is to run this, of course. So I am going to go over to the REPL mode of this. And if you remember, yesterday I had to do this control A, then control B. Right? So it is in the REPL mode. Also, let me zoom in a bit so that it is visible to you all. I am like there are multiple ways to run this. I am going to use the execute way where I can do exec, which is execute, and I can say like open what is our file name? It is blink underscore with underscore patterns dot py file shows it dot read. Okay, so this is the command that I'm running, and it is starting up, and it is hung a bit interesting. Okay, let me do import machine and machine dot reset. This should reset everything that I have up and running. Next up, let me try first to import blink with patterns dot import blink with patterns. Like it's not giving an error. Perfect. Okay, cool. It is not giving any errors. Now let me try this. Okay, seems like it is refusing to work out. Let me just do the Okay. Let's see if one of the functions. Okay, it is running. Weird. Uh, and it's up. Cool. So it does work for sure. And it was running before this one. I wonder what changed between that and this. Why is it stopped? Let's try pattern slow. Just confirming a few bits and pieces. Just give me a second. So it does work. As you can see, this is the blue LED onboard hardware LED, which works. So even that worked. Is there, and the SOS feature works. Mhm. What about the hard? Unless there is an error in what am I doing? This is the heartbeat pattern. There we go. Oh, I think I'm missing a bracket. Ah, there we go. Perfect. So this should run all the buttons one by one. So it ran the fast blink already. Now it is running the slow blink. Now it is running the SOS and heartbeat, and it will keep on doing it. Okay, so it will keep it running in the loop. Okay, all because I missed a bracket. But thank God we successfully checked it out. Okay, so as you can see in the code, I have a while true, so it will keep on running it in this loop again and again and again, unless I do a keyboard interrupt where it will finally just shut off the LED and we should kind of come out of our program. Okay, so or exit out of our program. That's what I wanted to say. Cool. So definitely works. I was missing a bracket right there. And let me just do a control C, demo stopped, and the blue LED flashing has stopped, and that is done. Okay, so things that I tried out, or actually, let me put these in the README. Okay, this is one way. I'm not sure if it works, or you can basically do MP remote. Oh, soft reset is also there. What I want to do is, oh, MP remote connect this and a REPL. Then you can inside this you can do machine dot reset, or you can also do import machine and machine dot soft reset. So these are two ways to reset the device. I have no idea if this works, so let's try it. This one is AI generated, but we should always ensure that it actually works. Okay, verify all the generated outputs. Okay, it did not give any output, unfortunately, but it did not give any error. Okay, soft reset is not a command. Soft underscore reset possibly. Let's try that out. Okay, so this is definitely not the right command. I would not uh, also believe the other one because I'm not sure what it does. It does not output anything. So this is my preferred way. Uh, Performs a hard reset. Yes, this is kind of correct, which restarts the micro without what? Yeah, without rebooting the entire device. Okay, this is perfect. So this is for resetting the device and to run a program. Let's see. Yeah, we can do a run. We can call a specific function. We can do execute, or other way is to basically go into the REPL and we can do what we did right now. Uh, okay, execute, open the file name.py dot read, and yep, this is what we did. This extra back was the main thing slash the missing piece which I had before, which is why it gave me that dot dot dot, but I didn't realize what it means. Excuse me. Okay, I think this is good enough for details. So let me just quickly push this. Uh, this is session 3. Add a reset and a run command. And get pushed. Perfect. Okay, so successfully have run the blink pattern that we have successfully have, I think, tried out a bunch of things. One thing that I want to do in quick connect, which is Wi-Fi, and I won't tell you. Don't worry, this I changed it just for the sessions, and I will change it back to my original after the session. Okay. A few things that I want to do is I want to delete everything that I have on my device. So fs rm. First, let's see what do I have. Okay, these are the files that I have. Uh, uh, uh. So of course I was trying it out uh, over like for this session. What did I do? Fs rm. So I'm going to delete multiple files. Let's say going to delete this. Going to delete install.py. Going to delete led underscore server.py. So these are the files that we will create over. And going to delete simple dash server.py and Wi-Fi underscore connect underscore small.py. So these files have not been created yet. So you will not have it, of course. Uh, I created most of it when I was practicing for this session to ensure that everything works fine. Which is when I created these and I did not delete them. But now I have, so that should be good. I'm going to copy over just this quick underscore connect.py over to quick underscore connect.py, and I will also need the connect Wi-Fi file, which comes from Wi-Fi connect. So let me also just paste it over. So this is just to ensure that I can connect to the Wi-Fi. Okay, perfect. And I can, let's try one of the commands that we have for running a program. We can just do this one. So I'm going to do that, but instead of file name.py, I'm going to do quick underscore connect.py. And it's, oh, oops, that is the wrong ID. It is please underscore UAD. But our program works because it failed to connect to the Wi-Fi. Wait, let me confirm what is my Wi-Fi name. Forgot. So this is what happens when you change it for this session. Yep, this is perfect. So I'll need to copy it over again. And now I can run quick connect. Okay, these two are correct. May need to reset possibly. Oh no, finally. Uh, attempting to connect and already connected and successfully connected. Perfect. So we have successfully connected to the Wi-Fi, which is nice. Okay, so what's the next bit that I want to do? I want to build a server, and no surprises there. I think you saw that I'm going to call it simple server. So what is this server going to do? This simple server, it is going to uh, create a web server on ESP32 so that we can control the on-board LED on ESP32 using what's the word? Using a UI. Okay, so we'll build a UI. We'll host a simple HTML page with minimal amount of CSS, and that one is going to kind of give like it will have two buttons. It will have like turn the LED on, turn the LED off, like very simple. But all I want to show is how you can connect to Wi-Fi. So it will be independent of everything that we have here. So it will ensure that what do you call it will have its own Wi-Fi connect page. So we'll create a very simple Wi-Fi connect. It will have functions to create its own web page. So inside the Python file, we are going to write some HTML. Not a very good idea, but it will work out fine. So don't worry about it. Uh, so that, and then we'll create a simple web server where we'll first connect to Wi-Fi. Then we will start a server which will listen to any instructions that come on to that particular port number that we have. And then yeah, based on those instructions we will control the LED. Okay, if that all makes sense, very good. If not, as we start writing it, it will start making much more sense. Okay, cool. So I am going to do one last thing. I'm going to disconnect from the Wi-Fi. I'm going to do REPL. I have a disk in Wi-Fi connect. We can do import Wi-Fi underscore connect as W. Okay, and now I can do W dot status to check if I'm connected to Wi-Fi. Yes, I am. And now let me do a disconnect. Okay, all these methods we wrote. I wrote few of them yesterday, and it is now disconnected. If I do status again, it is not connected. So that works perfect. Nice. And Control X to exit out of the server, and let's go and create a simple web server. So I'm going to call it simple web server dot py. Okay, simple web server dot py. What it is going to do is it is going to basically try and start a web service which we can access from any device which is connected on the same network. So if my phone is on the same Wi-Fi network, then I should be able to access uh, this. Okay. Can move away from screen so that you all can focus solely on the code that we write. So let's start by kill these two. Okay, more space to view the code. Okay, I'm going to import a few libraries. So we are going to import the socket library. We are going to import the network library. I have no idea what is network X. Of course, we're going to import the time library so that in between the Wi-Fi connection, as I said, this will be independent of any of the other files. Okay, so it will have its own Wi-Fi connection code. It will have its server code and ensure that this can run independently. And from machine input pin, yes, so this is to control the LED itself. Okay, next up is just perfect. I think this is awesome. We have done this in the blink.py as well. Okay, we are setting the pin 2 of our ESP-32 as an output pin because that is where the LED is. Uh, okay, and starts viewing things, which is good and bad because I want to write it. I'm going to say connect Wi-Fi, and I am not going to give it any params because we are going to set it uh, on the on the what do you call it? In the function. We'll hard code it in the function. So SSID is going to be like, make sure that this is the name of your Wi-Fi. So for me, it is this one to do. Yes. And the password is, oh, it thinks my password is this one. Nice. Nope, this is not my password. Is I will. Okay, cool. Next, to connect to Wi-Fi, we know that we have to do WLAN equals network.wlan network.stai underscore if, which is station mode. The alternate we talked about yesterday is the AP mode, where ESP32 will create its own Wi-Fi network. Then active to true, and if no, not ID, if WLAN dot is connected, then in that case we can say yep, uh, already connected to Wi-Fi. But right before this, I'm going to say IP equals WLAN dot if config. So this should tell me, oops, IP. So we should, I would prefer to actually print out connected to Wi-Fi. Yes, perfect. And we can return the IP address. Okay, so this will print out what is the IP address of the server. Oh, sorry, of the Wi-Fi that we're connected to, and this will help us ensure that we don't try and reconnect again and again. Okay, so this is where we connect to it, and hopefully this is the correct detail. Okay, all like your SSID and password, they need to be correct. And once you have those SSID and password set, actually, I can do it after this, right? I can basically start with this, and if it is not connected, then in that case, let's set the SSID and password, because you could use one of our previous functions. Example, you could use the quick connect one, where you have already connected to the Wi-Fi using the quick connect bit. So it would be just garbage value SSID and password if you are already connected. Uh, let's print something. I'm going to say, yep, connecting to Wi-Fi uh, with this SSID. So this will help you know, okay, I'm trying to connect to this particular Wi-Fi, and then we can try and attempt the connection bit itself. Uh, this is fine, and this is fine, and this is where we connect. Okay, good. And we will try for like this doesn't make sense. In a range of 10, that should be 10 seconds, right? We can say if this is connected to Wi-Fi, and this is good. Print and okay, perfect. I think this should be fine. Okay, so what have we written? So we are saying that we'll wait for like 10 seconds to establish a connection. So in those 10 seconds, if we actually see that it has connected, then we are repeating the same bit again, where we'll print out, oh yes, you have connected and this is your IP. And we'll try again if like 1 second. Okay, we'll try wait for 1 second, we'll sleep for 1 second, and then we check again and attempting to connect, and then it will again attempt to connect and go inside this for loop, and this will happen for 10 times. And if we are able to connect in those 10 instances in those 10 seconds in this case, well and good. Else we have basically reached outside of that for loop, and we are going to print that oops, we failed to connect, and we return nothing from here. So that is our connect to Wi-Fi code. And I am going to leave this as is so that I don't mistakenly uh, push this. Okay, what else? Nothing from here. Let me like I'll try and push this like multiple times. Uh, from yesterday, if you have not activated the environment, then make sure you do. So here's the ESP-ENV that we had created yesterday, a virtual environment to ensure that we don't have any conflicts with our global environment. So do activate it before you do anything. Get status. This is fine. Things that I have changed. Yep. I think this way your Wi-Fi name and your Wi-Fi password is better in this case. And in here, all we did was create this file, and I'm going to keep it same. Your Wi-Fi name, password. That's what it's written for. Your Wi-Fi name, your Wi-Fi password. Not git add, git commit. This is session 3. Simple web server part 1 and git push. Okay, and if you don't have the GitHub repository yet, once again, here we go. Okay, there is a question. What IDE am I using? Oh, Visual Studio Code. Here we go. A link to download Visual Studio Code. Okay, let's move ahead. So that was connecting to the Wi-Fi. The next function that I want to write is the web page function. So, booyah, uh, autocomplete. I'm going to write. Wow, seriously? No, web page. Okay, cool. So this is where we'll write a code to generate a HTML web page that the user will see in their browser. Okay, it is going to return a string, which is the whole of HTML web page. So uh, the code that I want to write is first check what is the current LED status. So is it on or off? Then it will also have like the HTML itself will have uh, buttons for on and off. The way it will work is it will try to send a request, excuse me, send a request on forward slash on and forward slash off URL. And all the CSS will also be inline in this case. Don't want to have like a separate CSS file and a separate HTML file. Like I don't want to do all of that. So I'm going to keep it as simple as possible. Uh, let's see what this one generates. That would be interesting to know. Okay, cool. So I'm going to start with first checking what is the really okay. Cool. Yes, led.state if the value is equal to 1. So we know that led.value can have value as 1 or 0. If it is 1, then it will return on, else it will return off. Okay, I want to do another thing. I want to set the color. Uh, okay, yeah, this is also fine. So hmm, cool. This is for the web page. And just to ensure that everything is formatted nicely, I'm going to create an index.html, which I will delete. Okay. So this is to ensure that I have everything set up properly. I don't really need much of this. I'll just say LED controller. And in the body tag, I am going to have a title, which will be ESP-32 LED. And this is actually, no, not title here. Sorry, that is my bad. I am going to add the title here, that is fine. And I'm going to also add some inline style, okay, in the head part of the code itself. So here, let me, what is it generating? Body margin 0, padding 0, background color is this. And nope, I don't want that background color. And overflow hidden, which is fine. I'm going to ensure that the text align is center, and we have enough padding actually. Let's go for 50 pixels. Okay. So this I'm creating just to ensure that whatever code we write, it is properly and nicely formatted, because if I add it as a string here, it won't be clearly understandable or visible. So actually, let me call this temp underscore temp.html. Easier that this is going to be temporary. I can't stress on it enough. So we have doc type HTML page. Language is English. The meta character set and the viewport, these came by default. We changed the title to be called as LED controller. I'll say ESP-32 LED controller. Okay, cool. And we are writing the styles for it. So the body tag itself. Okay, cool. Let's go ahead. Sorry, as I was saying, where was I? Oh, I was talking about, okay, the body tag itself. Uh, hmm, Let me set the font family to be the basic fonts. Let me also remove this. It's not really needed. The H1 itself, we can say, yep, I think this should be good. What else? We'll have two CSS, I would say, dot status. And I have no idea what this has written, so I'm going to update it. I'm going to say that the font size, I'll go for pixels. So let's say 24 pixels. And the color would be the color that we actually read from this one. Okay, so this variable. So color will actually be the color. Let me call it status color so that it's easily understandable. Okay, status color. And that would be the color. And we can add some margin around it. So let's say 30 pixels of margin around it. And as you may notice, it is not faring well with this one. Okay. So the reason why, because once it gets converted to a string, we'll use something called as a template string. Okay. So that will be uh, like curly brackets inside curly brackets. We don't have that yet here, which is why it is failing. So I am going to leave this for the time being and ignore the error, because we can still have everything up and running. I think this is fine, actually. Like these two statuses are fine. Style itself is done. I'm going to comment this out to ignore the errors. And what else? So this is the head tag done. And now let's focus on the body tag. Okay. So this is where, yep, LED controller, a div with class of status. LED is currently in this state. LED state, not LED status, LED state. That is what we have called it. And okay, perfect. So div is done. And now we'll have a tag with a href, which will send a request to slash on. We can give it a class of on, and we will say this is turn on LED kind of. and we will send a request to slash off. We can give it a class of off, and we can turn it off. Okay, so I think that should be it. We can add a status for the dot on bit, and that is a lot of colors. I'm going to just go for minimal. We'll say background color is going to be uh, dark green, and for the dot off, oops, spelling mistake, dark red. I think this is good enough. Uh, you can also style the A tag. Actually, let me finish it. Finish the A tag styling as well. I have no idea what the style is. I have just chosen what it gave me. Okay, so this is our temp.html. There is this one bit which we'll need to uncomment. And now let's see how it fares on our web page. So I'm going to create a quick variable. Let's call it HTML equals to, it is going to be f strings, of course. And we will start with this one and end it here. Perfect. So this is nice. And as you can see, there are a few errors. So we copied and pasted everything that we wrote from there directly, which is fine. But this inline CSS does not fare well right now. So in style, in the body part, I will basically, to make it a template string, you just have to wrap it inside double curly brackets. So this is one way. You can reduce the spacing if you want. Let me first ensure that everything is in like single curly brackets, and this one as well. Let's do this, and this one as well. Sorry, double curly brackets. Did I say single? Sorry about that. Oops. Okay, so this is correct, and this is correct as well. Awesome. Now what I'm going to do, just to ensure that this does not take up so much space, I'm going to cut it. I'm going to go over to a new tab, paste it so that all of it is in line. I'm going to paste it right here. And now let me just hit enter a couple of times to give you a nice little kind of change here. I can also add some inline comments. For the time being, I'm going to leave this as is. Okay, so that is it. LED state will come from this variable. Status color will come from this particular variable. And the HTML is what we are going to return from this web page. We wrote all of it in this temp.html. Oops, did I do a cut paste? Okay, yeah, we wrote all of it in this temp.html. We copied it over to this one, to the webserver.py, simple webserver.py file, and we realized that, oh, it does not go well with the curly brackets, so we had to make it in the template string, so we just had to wrap it in an additional curly brackets, and that did the trick. H1 is right here, so body tag, h1 tag, dot status, this is the class name, a tag, and the dot on class name and dot off class name. Did we give a status? Yep, class status, class on, class off. Okay. Cool. I think this is good enough. Let me delete the temp.html. Don't really need it. And let me push the part 2 of it. Oops. I don't need a new terminal. I already have one. Git status. Okay. Git add all. Git commit session 3. Simple web server part 2. And git push. Excuse me. Okay. Hopefully you all have access to it. The way to look at the commits, I would say, is just go into the commits look what happened in part one, so that if this green basically suggests this was a new file that was created, and this one only had, like, this is gray in color, which means it had some additions and removals. So the file should have existed beforehand. Then in if you have copied part one, then you go into the part two bit and you can see, oh, these are the changes that happened between part one and part two, so that you know exactly what to add and what to remove. Okay. Okay, cool. Let's move on to the next bit. So we have created a web page. We're going to return that web page as HTML. Now let's write some code to connect to start a server, and we will say start underscore server. It will not have the IP. No, I don't need the IP. So this function, what it will do is it will start a web server. It will handle any incoming requests. Where are those requests going to come from? These A tags. Okay, when we run the web server, it will run this HTML page, and when someone clicks on these A tags, which are nothing but buttons in a way, as you can see, uh, they will send a request on /on and on /off, depending on what you have clicked. Okay, and based on those requests, uh, the server will handle it. So it will handle the incoming HTTP request and pass on some instructions. So things that we will do in, like, let me come on screen so that it makes sense with my body language what I'm talking about. So the things that we will do here is we'll connect to the Wi-Fi first. We will create a TCP connection and bind it to a port. Okay, what that means is you can visit an IP address, but the IP address will not just be the IP address. It also needs a port number attached to it. We'll use the standard port, which is port 80 for HTTP requests, and for SSL or HTTPS, I think it is 243. And okay, so this server will start. It will listen for any incoming request. If the URL that the request is coming from has /on, it will then change the LED to on status. If it is coming from /off, then it will change the LED to off status, and this will keep on happening. So the server will keep on running in the background until someone interrupts it by doing Control C. But you can still do something like not interrupt it with Control C and ignore that keyboard interrupt thing and leave it on forever, right? So the server will keep on running forever and ever. Okay, so oops, let's go ahead. Let's first say, okay, so we have the connect to Wi-Fi. That should return an IP. We know that for sure because that's what we did at this point. Sorry, at this point. Okay, at this point as well as this point. So if as soon as we are connected to the network, it should return us the IP address of the network that we are connected to. So this is fine. And if not IP, okay, then we can just print something. Yep, this is nice. Exiting. Okay. So this means that the connection has failed. So the start server function will run and it will wait for the IP address to come back. But if we do not get an IP address, and this will run for 10 seconds to try and connect, if we do not get any IP address back in 10 seconds, then in that case, it will just print this message and that is done. Okay. Next is I have no idea what this is, but we are going to basically create a socket stream. So socket library is what we have imported, and okay, yeah, this is correct. So what are we doing in this case? So what does this mean? So this is AF underscore INET, which means it is an IPv4 address. Okay. which is what we are going to get from our IP. And this sock stream bit, this is nothing but telling it, oh, it's a TCP protocol, and TCP protocols are reliable, connection based. Cool. Uh, okay. Is this correct? SOL socket, reuse address and one. Okay, perfect. Yeah, this is good. So what are we doing here? So sometimes, and this is what I found even during my testing, that I would start up a web server. I would do a control C to exit the web server, but it would still say that. And if I restart it, it would say, "Oh, I cannot restart the server because the socket is already in use." So then I googled and I found that, oh, yeah, what we can do is we can set this SO reuse ADDR, which is to allow reusing the port immediately. Not socket already in use, it would say port already in use. So this will ensure, by adding this, we'll say that as soon as the server closes, free up that port so that when you restart it, then it will not give you that error already in address already in use, port already in use error. Okay. This happened like if you get that error, you'll have to do the machine soft reset and machine reset. Like you'll have to basically restart your ESP32, connect to Wi-Fi again, or you may have to do a soft reset. Okay, so this is to definitely avoid getting that address already in use error when we restart. Okay. And I will say, I don't know what this is doing, but I am going to actually change it to say 0.0.0.0 and yeah, port 80. Okay, cool. So what is this doing? So we are binding, or you can think that we are going to listen. Okay, our socket is going to listen on a certain IP address and a certain port number. The port number, as I said, for HTTP, standard HTTP port is port 80 and 0.0.0.0. This means that you are going to listen on all available network interfaces. Okay. Otherwise, if we say that, oh, you only listen to a particular port number, like if you get a response only from this particular address and this particular port, then and only then respond to it, that is also cool. That is also good. That would actually be a better practice. But what I want to do is not basically set that IP address or port number there. I'm going to listen to everything just to ensure that I get the response back from any device, okay? Any device coming from any IP in this case. And yep, this is good enough. Okay, this is also good. So s dot listen, here we are saying that start listening for connections, and this 5 means that uh, the max number of queued connections in the background. Okay, so we will respond to 5 connections that are sending messages in the background. Okay. uh, Actually, let me just change this to listening on this particular address and port 80. Okay, this is what we are doing. And we can also, like, I'm going to ensure that on keyboard interrupt it stops everything. So let me just also print that. Yep, this is good. At some point it starts feeling like it's listening to me. uh, okay, cool. Perfect. So now let's write the try and except block. Now inside our try we will have a while true bit here, and except if you receive any keyboard interrupt. In that case, we will say server stopped, we'll close the socket, and we will ensure that the LED is turned off. Okay? The LED that is globally defined here is turned off. So now inside the try bit, let's start writing the try bit. And this is where the magic will happen, where we will accept connection. So while true, now we will get two things from, oops, is it really like, okay, so we'll get two things from the socket. If when it accepts an incoming connection, okay, it will give me a connection object, and it will give me the client's IP address and the port. So I'm going to get those two things. Okay, perfect. And of course we can print it out, which is what it is doing right now. I'm going to say connection from, oops, connection from this particular address. Okay, so we have received input. So from ESP32's perspective, it is receiving an input, right? So from ESP32's perspective, the input is like the socket is accepting connections and it has received an input. And we are just printing out, oh, where did you receive it from? What is the address of the sender? Now we can have, okay, request is a better word than what I was thinking. And RECV and 1024 bytes dot decode. Okay, perfect. So what is this? So this is basically when we get that connection object, it is going to be of some bytes. We are going to say that read up until the 1024 bytes, which is good enough. Like quick Google search will tell you like this is what you will get from an IPv4 address, and then you have to decode the byte. So this decode will convert it from bytes to a string in UTF-8 object. Okay? So UTF-8 connection, UTF-8 conversion to a normal string. Use UTF-8 to decode the bytes to a normal string. And yep, we can also print out the request. Now, if yeah, this is good. In this case, this is good, and we can say LED is turned on. Uh, else if it, okay, so if we receive, so now this request, okay, this will have 1024 bytes. So what are we going to listen for? Remember this forward slash on and the forward slash off. So if the request contains this forward slash on in it, so once we have converted it to a string, we can read it. And if that contains forward slash on, then we turn the LED on and we'll print out that, oh yeah, the LED is turned on. And if it contains slash off, then we'll say LED is turned off. Okay, so we are just building, uh, we're just printing it out, and we are also controlling the LED in this case. Okay, and now we can respond back. So I'm going to say response equals to, I'm going to follow, wow, nice. Okay, cool. So we can do it in multiple stages, but okay, cool. So what are we doing here? So we receive a request, we do some action, and then we want to tell the sender that your response has been successful. So this is the header bit where we are saying that it is 200 OK, which means that it was a successful request. If we have received these two things, then in that case, it was success. We have received it. Then we will say that the hey. The response is going to be an HTML. And as soon as we have kind of worked on the request, we will close the connection, and we will also update the web page. Okay, so we are going to send back the web page. And after this, we can just say, yep, this is good. And we'll close the connection. Okay, so this is the header. This is the web page that we will send back, and the web page is the one that we have created. So this is the one that the user has, as well as this is the one that gets updated. They'll get the same web page back as the response. We will send back the response, and if decode converts bytes to string, then encode will convert the string to bytes, right? And HTML web page is going to be a string, right? And as we said, like, we have told the user that, hey, the connection will close after this, and we are doing exactly that. We are just closing the connection. Perfect. And finally, let's just, yeah, if name equals to main, start the server. So this should take care of everything. Now let's try it out. I am going to, actually, let me push this first, and then for any errors that we find, we can kind of resolve them. Yep, three parts so far. Okay, so a moment of truth. Let's Step one, we need to copy over the simple web server.py over to the file, and I'll create a same file name on our ESP, and there we go. It is copied over, which is nice. And let me just quickly check the files that we have on our ESP. Ah, before copying it over, I should have, and I need to, actually, not should have, I need to fix this one. I need to copy it over again. Okay, simple web server is copied. Ooh, 3039 bytes. That's a lot. Like, you can simply reduce bits and pieces from this code, of course. Like, you can make it simpler. You can remove the connect Wi-Fi functionality from here, uh, or at least remove all those print statements to keep it minimal. You can, or another thing, if the debug, like, you can have a debug mode, so you can keep all the print, all the, but that will still have increase the number of bytes and stuff. Okay, not sure what we can do, and let's try it out. Moment of truth. Let's run it. Connecting to Wi-Fi, attempting to connect, attempting to connect, attempting to connect, and it has connected finally. So 1, 2, 3, 4, 5, 6 seconds. It took 6 seconds, and it is listening on this one. Let me just copy it over. I'm going to go over to this page. The LED is currently off. Where are my buttons? uh, okay. If I send slash on, okay, LED is currently on. I needed some buttons there. And let me come back on screen. Okay, it is currently on. It has received connection Okay, you can see all the details of the connection itself. Okay. So step one, when it loaded, this is what happened. And oops. Hmm, okay. It loaded connection was keep alive, but I should have closed the connection at some point. LED turned on. Okay. And now if I send a request on slash off, LED is currently off and it turns off. Okay. LED turned off. It received a request from this one. So this IP address, and cool, this works. I think it's logging a lot. Maybe I can remove a few things. Example, I can remove the request itself. I don't really need it. That's one thing. And I needed two buttons. Why do I not have buttons? Because this one is not a button. I should add buttons. Oh, they are there. They just don't look there. Okay, interesting. Ah, bad idea. Blue? No, I need the background colors to be set for this. Color white is fine. I need a background color. Oh, spacing. Ah, there we go. That's where I messed up. I don't know how that happened though. Radius, text decoration. Okay, cool. Let me stop the server. Actually, let me just show you one thing. So if I go to slash on, okay, LED is on. But if I do an interrupt, it should hopefully shut. It did not. Okay, so our if else condition also has some issue. Uh, do I not? I do turn it off. Oh, close the socket before I turn it off. Oops. I think this should work out. To start server, or I can basically move the try catch here. Hmm, okay, there are a few things that I have changed. Network is used, machine is used. Okay, cool. Let's try it out again. I'm going to copy the code over. Sorry that you have to look at my face enlarged, but let's see. Okay, it has connected, and if I reload, there we go. Perfect. So there was a space in between. If I do turn off, the LED is off, the blue LED. Okay, that's what we are focusing on. Turn on should turn it on. You see a refresh happening because that is what we are getting back as a response. So this is our server sending a response back, which is the whole HTML page with this bit changed. Where is it? Uh, this LED is currently on. So this status will have a color which will change. So if I do off, it should send me a response back of off, and it will have status changed. Okay, this is not updating anymore. Oh, because am I on off? Okay. Turn on and turn off. This is not painting. I need to see why is it not getting repainted. I have to refresh it, which is bad. But otherwise, well, that on and off bit works for sure. On, okay, and I'm going to click on off, and that works. Perfect. So it does work. There are a few things that I need to take care of. Example, this comes back, but it does not refresh. Okay, so if I do off, the URL here says off, and it also turns this off, but it does not paint the browser page and does not show that, oh, it needs to show this particular text until I reload. Okay, which is the problematic bit. The So I need to basically figure out what's going on there, and let me try turn on. So the LED is on. Let's see if the keyboard interrupt works. Nope, that didn't work. Okay, I'll have to also figure that bit out. Why is the keyboard interrupt not working? Excuse me. But I think that is the perfect place to okay, perfect place to stop. I am going to change this to be sans serif. Because I think that is okay. It's not sans serif. Let me copy this over to HTML itself. Oh, is there a problem in the font family also has a problem? Okay, all the dashes one had a problem. I think this happened when I did that open bit, uh, paste it in URL, but it seems to have affected only a few of them because like border radius, I think that is correct currently. Yep, it has 5 pixel border radius. Background color. Anything else that I can fix quickly? Uh, okay, things that I've changed. So background, the font hyphen family, there was a space which I changed. Uh, there was also a spacing between something else. Font size had a problem. So that I changed as well. I think this should be fine. Let me copy it over. Okay. So now the font family, what I wanted. Yep, that is correct. And in the network tab, I can see on coming back. The response is correct. Off coming back, the response is wrong with respect to the color green status. So that means the status color bit is wrong. I can basically try and see Green if LED state is on, else red. So LED state does get updated. So I can change the status color depending on the LED state. Okay. Let's try this bit out and see if it actually makes a difference. All I can assume is that the refresh is not happening, and it was happening before. So it worked the first time, it didn't work the next time. LED is off. So it works the first time because it goes to the /on route and it returns the right thing. Then I try the off bit. It goes to the correct route, but it does not refresh the page, which is the interesting bit. Okay, I think that's fine. I'll figure it out later and push this. How is it working? If I, oh, because the connection is still there. Oh, no wonder. So remember that I said like you may not disconnect from the Wi-Fi. So like I had changed the SSID and password. I copied the new file over, but it was still working even though I did not have the correct details of Wi-Fi. How? Because it was basically it remembers it from the previous connection. It has not closed the connection. So that is the interesting bit. And let me try it from my phone if I am connected to the same Wi-Fi network. So I am connected to the same Wi-Fi network. Let me try and open this IP address. It is 192.168.1.201. My Wi-Fi is not working on my phone in general, which is weird. Yeah, finally it connected. Okay, so let me show the Wi-Fi. So on my phone, I am on that IP address, and let's try turn on bit. So I sent the request finally, and there we go. It's turned on. Okay, let me try turn off from here, and it turned off. You actually also can see it on the console, so it does work. Nice. It also changes the URL. So can I like hold it? Can I hold both of them? Let's try. So it's currently off, and let me try and figure out on. Let me try and figure out off. Perfect. So on the same IP address, like if you're connected to the same, not same IP address, if you're connected to the same Wi-Fi network, excuse me, connected to the same Wi-Fi network, and you can visit this page, then it works, right? Perfect. Okay, now I'm having fun playing. There's one thing that I noticed, which is like on phone, uh, if I do it repeatedly, the status does get updated. So if I do on, the status part does get updated. Off doesn't, but if I do it twice, it works. On works the first time, off doesn't. So it's going to be a fun debugging. Oops. Off, off, on, off. Okay. So it's going to be very fun debugging what's going wrong, because definitely during my practice that didn't happen. Uh, so I wonder if something that the LLM gave me is not working out properly, or maybe I messed up somewhere, which I can't figure out on the call. But that's fine. I think this is good enough to push. Hopefully, I've not sent over my Wi-Fi. I like name and IP. I think this is fine. Acceptance is fine. Sending the request is fine. This bit is also very interesting to me. So I'll have to take a look at that. So it does get the keyboard interrupt, and this time it actually worked. System exited, and there we go. There was a keyboard interrupt, and it turned the LED off. I don't know what it was before though. Nope, I don't think it actually worked. Uh, I should possibly have a stop server. Maybe this will help. I'm going to add a comment because I've not tested it out. AI generated. Okay, I've not tested that out, but that's fine. Like, regardless of whether it works or not, I think in general, a connection to Wi-Fi works. We have seen that it actually sends the request and response, and yep, that's a simple web server up and running. Let me do a quick git status. Hopefully, everything should be fine. Uh, Nothing out here, and let me do a git add, git commit, session 3, part 4. Git push. Okay, and here you go. All the commits right here, and you can have a quick look. We have like 15 minutes, and I'm not sure if that would be the perfect time to start the project, but we can, uh, like, I'll give you an overview of what I want to do, and when you come back, uh, I would have created some fake data already on GitHub. So keep an eye on the GitHub repository, because I'll have some fake data created right there. And that fake data is going to be some details, uh, like some fake details of some, let's say, users. And I'll try and create some of the things. Example, I'll create the HTML page beforehand. Okay. Why? Because I think that ways we'll end up wasting less time, and we can focus more on the actual piece of code. So the HTML page, I'll try and create it beforehand, uh, and push it on GitHub. I can walk you through the code, of course. I'll show you, oh, this is what we are doing, this is what happened, this is where it works, and this is what it would change, stuff like that. So I'll show all of that to you. But in general, I would say, yeah, I'll finish up like 40% of work, and it will be pushed on GitHub. So we'll spend like first half an hour in the next session talking about, uh, what's the word? Talking about what I have already pushed, and then we'll spend the next 1.5 hours writing the piece of code that I actually want to show you, and we'll take it from there. Okay, I think that is perfectly good enough stopping point. Now, if I can request you all for feedback, please, I'd be very grateful if you can provide me feedback. Any constructive criticism would be appreciated. As I always say, so if there's anything that you liked, let me know, let MLH know. Anything that you disliked, let me know, let MLH know. This was part 3 of ESP-32. Give me a rating. Should not take more than like 3 minutes to fill this whole form. Uh, so yeah, please do that, and keep an eye on GitHub. But I will, when we come back from an 1 hour break, an hour long break, then we'll continue with the fourth and the final part of building ESP-32, hosting a website on ESP-32. Okay, right now we have hosted it, but it only works on my local Wi-Fi. Okay, so we can connect to it from any device as long as we are on my local Wi-Fi. Okay, so we need to think of a way to take it further. Okay, connect it from anywhere in the world, technically. So yeah, that's what we are going to do. And any questions, anyone, before we end this session? Okay, nothing. So I'm going to take the silence as golden. I'm going to assume that you all understood everything that we did. All the code has been pushed, of course. Oh, I just realized I did not write an instruction.md file for this one. I'll do that maybe after the fourth session, and I'll update it and push it. Okay, cool. No questions, anyone. Thank you so much for joining. And I will see you back in an hour where we do the fourth and the final part of hosting a website on ESP-32. I will post an announcement on Discord. So don't worry, you won't forget. And just take a quick break and then just come back. Quick, not quick, 1 hour break, and then come back to join the sessions. Cheers. Thank you.